So hi, welcome to my YouTube channel. Today we are going to discuss the main important points, the main key takeaways about the naive-Bayes classifier that you will be frequently tested during a data science interview. Again, keep in mind, we are not going to discuss the intuition and the mathematical formulation behind the naive-Bayes classifier. This particular video is completely focused on those important takeaways you should know before appearing a data science interview. So let's dive in. The first point which you are often asked during a data science interview is regarding what are the main assumptions behind a naive-Bayes classifier. Keep in mind, one of the most important assumption, which actually is very important for an interview perspective, is that the features are assumed to be independent when you are dealing with the naive-Bayes classifier. The naive-Bayes classifier is a probabilistic classifier based on Bayes' theorem, which assumes that each feature makes an independent and equal contribution to the target class. Naive-Bayes classifier assumes that each feature is independent and does not interact with each other, such that each feature independently and equally contributes to the probability of a sample to belong to a specific class. So the main key takeaway is that the naive-Bayes classifier assumes the feature to be independent. Let's move forward. Now, what are the advantages of a naive-Bayes classifier? Again, a very common interview question for data science uh, candidates. Keep in mind, when you assume that the features are independent, just holding now this criteria, the naive-Bayes model performs extremely well as compared to other machine learning models. The naive-Bayes classifier is simple to implement and computationally fast and performs well on large data sets having high dimensionality. It performs better with categorical variables. The convergence rate of the naive-Bayes classifier is actually very fast, and that implies less training time. So this means that this model needs a small amount of training data to give an estimate for the test data. So the period for training is significantly less. And to wind up with this particular part, keep in mind that naive-Bayes classifier is actually proven to be more useful when the data set contains many features. Now, what are the disadvantages? Now, one of the most important disadvantages which you should keep in your mind before appearing data science interview is that if there is correlation among the features, then the model performance will drop significantly. Now, in the naive-Bayes classifier, best performs when correlated features are removed because correlated features will be voted twice in the model, leading to an overemphasis of the importance of the correlated features. And again, so keep in mind, the main takeaway for this part is that if there is correlation among the features, then the model performance will drop. Now, some of the most important things which I have actually gathered during my years of experience in data science. So keep in mind, naive-Bayes classifier, linear discriminant analysis, tree-based models. So these models are not affected by feature scaling. Feature scaling is a type of feature engineering where we scale the features. But keep in mind, any algorithm that is not distance-based is not affected by feature scaling. One of the most key important point you should know before appearing a data science interview. Now, when I say distance based, it means you can talk about some clustering methods like dbScan or k-means clustering, which they uses the properties of Euclidean distance. Okay, but in this case, we are talking about models like naive-Bayes or linear discriminant analysis or tree-based models. Keep in mind, these are not affected by feature scaling. In As a general notion, naive-Bayes is considered to be robust to presence of outliers, but keep in mind this is not true every time. But then, yes, in some cases, in general, in more cases, we actually go with this assumption that okay, it is considered to be robust to presence of outliers. For real-time applications, keep in mind the naive-Bayes classifier uh, is not sensitive to noise. Now, this is going to be important if you're encountering a question in the data science interview that how the naive-Bayes classifier is going to handle missing data. Then for this part, I have done some research. I have read some research papers and have come out with this point, and I want you to focus on this. Keep in mind, for a naive-Bayes classifier, we use something called as naive-Bayes imputation, and that is used to fill the missing values by replacing the attribute information according to a probability estimate. So what it actually does, so the NBI process, it divides the whole data into two subsets. One is the complete data, and the second part is the data that contains the missing data. So keep in mind, the complete data is used for the imputation process at the lost value. Now this process is done on a repetition basis. So this process is repeated for each missing value attribute to generate complete data for classification. Now, so I just want to wind up with this video with this particular thing, that keep in mind, naive-based classifier is a supervised learning process. It's a supervised machine learning algorithm. So just keep this in mind, and this is very easy, but sometimes people do a mistake while identifying this. So thank you for your time, and I'll come up very soon with the next video.